we have another question: how to find omega of 1 with respect to 2 or omega 2 with respect to 1. Both are same, which is equal to v1 2 perpendicular divided by r, the distance between them, and the velocity of both relative perpendicular component. So in this case we had at t is equal to 0, we had L distance, theta naught angle, v1 velocity and v2 velocity. Since the v2 vector is along the line, the omega 1 2 simply is because of v1 sine theta naught. Since it has no component perpendicular to it, so the whole component perpendicular is due to v1 sine theta naught divided by distance of separation. So v1 sine theta naught divided by L gives the omega 1 2. Now, important thing, this omega 1 2 is the omega of line joining 1 and 2, and since the v2 vector is always along the line, we can say this omega 1 2 is equal to omega 1 2 omega line joining 1 and 2. Since v2 is pointing always along this line, we can say it is the omega of v2, it is the omega of v2 2. So if we want to find the acceleration of this v2 velocity vector, we can say acceleration is equal to a tangential plus a normal. It is two component. Since a tangential of this v2, since speed is not changing, a tangential becomes 0 because this changes speed, it becomes 0. Now equation of a normal is equal to v square by rc magnitude, or we can also write it as omega cross v vector magnitude. For the velocity vector 2, we can use omega of velocity vector 2 times velocity of 2. Since it is crossed and angle is 90 degree, omega crosses upward the pitch or downward, it is always perpendicular, and velocity is in the plane. So here we have the cross product becomes omega v1 into v2. Now omega v2 is equal to this omega 1 2 because the omega of this line is same as the omega of v2 because both are in the same line. So we can say that omega 1 2 times v2 is equal to a normal. This gives v1 v2 sine theta naught divided by L is equal to a, and we already found v omega 1 2. Okay, that was the case. And we had written this formula before too. Here, this was the formula for this a tangents, a perpendicular or a normal. How chasing problem can be of many times, but restriction for them is must. In this chasing problem, the particle 2 is always moving toward the particle 1, so its velocity is always toward the line joining them. So this type of problems are solved by this method, and we can also solve other questions For example, that famous triangle question, there was three particles. This is the length of equilateral triangle LLL. Each moves with v velocity toward each other. Now we know that as it moves with time, it always maintains its shape. Let's pick two particles A and B. A is moving with a v velocity and B is moving with a v velocity towards C. There is angle 60 degree. Now as it moves, it rotates in space, but the angle between them is always constant 60 degrees. So we can say that the dr by dt, the radial distance dr by dt, is equal to v1 cos the angle it makes with it positive direction is 120 degree, or we can simply say it is moving in this direction. We can say minus v cos 60 degree this direction plus v in this direction. Now integrating it from this total length initially was L and then becomes 0 with dt. It was dt, and integrating this from 0 to t naught. Now integration of distance gives this equation, and we can simply solve this. Now so the v1 velocity must be subtracted, it's a minus in there. We are finding the velocity of this b with relative to a, and the radius increases, so we will take minus 5 for this and subtract this velocity, so that the velocity we have here tells the rate at which the radius increases. This tells the rate at which the radius increases, and this is equal to dr to 0. We get minus L is equal to minus v by 2 plus v integration from 0 to t naught is t naught. Minus sign cancels out. We get L by v, so 2L by 3 v naught, if it is v naught is equal to t naught, 2 by L 3 v naught. We must be careful about when writing this dr by dt equation. If we are taking increase of dr by dt as positive direction, then we need to make sure that if this is positive in this direction, then its velocity must be subtracted if it is moving in this direction. Or you can write simply as dr by dt of b with respect to 1, which is equal to velocity of b, which is v minus v cos 60 degree. Since it is moving towards a, negative sign आएगा, and a is moving in this direction, and since it is a relative velocity, we need to subtract relative to a, we need to subtract velocity of a, which is v. This is the equation, and when we integrate drb with respect to a is equal to minus 3v by 2 dt, and we integrate it from 0 to t naught, and this integrates from distance of b changes from L to 0. Now this is how we do it. Simply use this relative concept. Now we have finished almost everything in kinematics. Now few things are left, like projectile motion, under gravity. Under gravity, we have some equations of trajectory, like tan theta x minus gx square by 2v square cos square theta by v square is the velocity at which it is thrown. Theta is the angle, initial angle by horizontal. This can be converted to this form where y is equal to tan theta x bracket 1 minus x 1 r. X is the x coordinate and r is the range, and all this and the starting point or initial point is taken as the origin for this trajectory. Now, safety parabola. We found out that when we use a given velocity, when we throw a particle with a given velocity, if we try all possible angles, then the particles will follow paths like this. It becomes a parabola. If we use a given v velocity and try to throw the particle at all angles, then the maximum reach we have is this safety parabola. The particle cannot go out of this. The particle moves always inside this safety parabola and can only touch it at some extreme, some special theta angles. And this shape is parabolic and its equation is given by this equation, and it can be easily made by this way. This length is v square by g. This length is also v square by g. This height is v square by 2g. So we can find the equation of parabola using this: x minus v square by g, x plus v square by g into some constant is equal to y. This way we can make the equation of parabola, and when x is equal to 0, this y is equal to v square by 2g. To satisfy this, we get k is equal to g something minus g by 2v square, something like that. Need to check it. Okay, moving ahead, we get some more questions. For safety parabola, since safety parabola is the extreme position of a particle at a theta angle for a velocity, means for a velocity, if particle is given a if particle is set to reach a point y naught and x naught, y naught, x naught, this is the position of the particle, then the minimum velocity it needs is v naught and is given by this equation independent of theta naught. So the minimum velocity by which we can throw a particle so that it reaches y naught x naught is v naught. This is the minimum velocity, and the angle at which we need to throw is this. And if we are said that particle is given a v velocity and x naught distance is given, and we are asked what is the max height it can reach, then it would be y naught, which we can find from this equation of safety parabola. This is same as this. We can use this equation to find y naught too. This is the max height at v naught x naught, and max distance at y naught v naught, and max v naught, minimum v naught at x naught y naught. These are the formulas which we can these are the values we can find with this formula. And the angle And when the distance of a point is given by x naught and particle's position, if particles reaching a maximum of x naught distance at a v naught minimum velocity at any point, then the theta for such cases is v naught square by gx naught, means the minimum velocity and the distance